Hello, and welcome to our 2:30 media availability on recent fires in the Amazon, California, and around the globe. Our speakers today are Danielle Touma from the University of California, Santa Barbara, Jim Randerson from the University of California-Irvine, Mercedes Bustamante from the University of Brasília, Mark Cochrane from the University of Maryland Center for Environmental Science, and Paulo Artaxo from the University of São Paulo. It's a little different than our normal press conferences. We're just going to have everyone give a few minutes of introduction about their research, and then we'll just open it up for questions.
Hi, so I'm Danielle Touma. I'm a postdoc at UC Santa Barbara, and my area of expertise is climate extremes in general. So I've looked at droughts, floods, and fires. I mostly use observational and model data to look at changes in these kinds of extremes in both the 20th and 21st centuries. Currently, I am looking at fires, and specifically, we're trying to parse out the roles of different anthropogenic activity on fire risk in both the 20th and 21st century. So we look at the roles of greenhouse gases, aerosols, and land use change on the risk of large fires over the globe. And so preliminary results show that if we zoom into the Western US, we find that greenhouse gases have already today doubled the risk of large fires in the Western US. And in the future, we find that under continued greenhouse gas forcing, the risk of large fires could actually triple. And then if we go to the Amazon, since that's what we're focusing on here as well, we find that greenhouse gases have also doubled the risk of large fires in the recent past. We also find that aerosols due to biomass burning have also had have caused an increase in the risk of large fires. And in the future, we also see that greenhouse gases could increase the risk of large fires in the Amazon by almost tenfold. I want to remind you that this is a model study, so there are some issues in parameterizing fires, but this is what our results show. And I also want to point out that larger fires become the new normal in both Western US and the Amazon as early as 2030 in some places. And greenhouse gases, from what we see, it's greenhouse gases that have really accelerated this time of new normal, while actually aerosol emissions will actually delay this time of emergence or time of new normal. So so we're hoping that our research shows that we really need to take different anthropogenic activity into account when we're looking at the future risk of wildfire over the globe.
I'm Jim Randerson from the Department of Earth System Science at UC Irvine, and I study global patterns of fires and how they're changing, as well as fires in specific ecosystems. And some of our recent results suggest that at a global scale, there's kind of a tale of two cities or a tale of two worlds where fire is actually disappearing in many areas from savanna ecosystems and from grasslands, ancient grasslands, with the expansion of global agriculture. And yet, as Danielle described, in many forest systems, fires are becoming more intense and are contributing to carbon losses. And so within California, our results suggest that increases in summer temperature extremes are creating more intense fires and also leading to a larger number of fires where it's easier to ignite a fire and have a fire escape. In Southern California, we've also identified that with climate change, we believe that these wind-driven fires that are very important in California, the winds themselves may not necessarily get stronger, but what's really critical for the fires is we believe that the humidity within the strong Santa Ana winds may decrease. And so with that decline in humidity, it actually increases the fire risk, even if the winds remain similar. And so we also had a result last year where we studied the age of smoke from Indonesian fires, and we're able to radiocarbon date the smoke and show that it was over 800 years old, confirming that we're really burning peats, and the burning in Indonesia will really contribute to the buildup of greenhouse gases and climate warming. So, thank you.
Okay, good afternoon. My name is Mercedes Bustamante. As Nancy said, I am a professor at the University of Brasília in central Brazil. My main research area is biogeochemistry, and I'm also studying land use changes in Brazil, especially in the savannas of central Brazil that we call as Cerrado, and also in the Amazon region, and the impacts of this land use change on biodiversity and ecosystem services. But actually my talk tomorrow will not about that, but will be related to the recent political changes in Brazilian national government. And these changes are actually resulting in a series of setbacks for environmental protection in Brazil, and also for the protection of indigenous rights, and also resulting in attacks to scientists and scientific institutions. So as Brazil is a mega diverse country with a lot of carbon-rich ecosystems, land use changes in Brazil are actually a global concern. And this is why this clashes between science and politics in Brazil are having a huge impact on environmental quality, including the fire season that we have this year. This was a peak in terms of the numbers of fires in the Amazon region and in the Cerrado region. But actually, these fires were not related to an extreme dry season as in previous years, but are related to human activity and linked to deforestation and forest degradation in response to the change in the environmental policies in Brazil.
Okay, I'm Mark Cochrane, University of Maryland Center for Environmental Science. I call myself an Earth system scientist. I really look at how fire works in the landscape. I started off in the Amazon and have been working there for 25 years now. I basically showed the dynamic of what happens once you get fire into rainforests, and how that basically becomes a positive feedback in those systems, where it gets more and more likely and more severe over time if you allow it to get started. Work other places like Indonesia, last several years, looking at the dynamics in the peatlands, both of what happens when they clear it, drain it, what's coming out of there. We've quantified the emissions in those landscapes, and also how it actually burns in the peat, and basically trying to provide the data so that we can make better estimates of the emissions in these areas, so that Indonesia can look at their efforts to try to mitigate these fires and hopefully quantify how much they're gaining. Work globally, looking at how climate change, say, fire seasons, and following out what Jim was saying there. We basically showed that area of the planet that's experiencing, say, extreme wildfire environments, basically the weather patterns, has increased by over 50%. However, it's not randomly placed. There are some places like the western U.S. and actually the Brazilian Amazon that are some of the fastest changing areas where we're seeing the most increased risk of such fires. So we're trying to look at all those patterns and have an idea of where things will burn and how. And so I'll be talking tomorrow also about where remote sensing comes in, and how we tend to be somewhat simplistic often when we look at it, how many hot spots or what we think's going on. We lose sight of what's happening on the landscape. So it depends on what our question is. It works fine for some things, but often we misapply it. And so I'll talk a little bit about that, trying to show what we can and can't do, hopefully.
Hi, I am Paulo Artaxo, a professor of physics at the University of São Paulo, and worked with biomass burning in Amazonia for the last 30 years. So basically what we saw in 2019 is a huge increase in deforestation. So about 90,750 square kilometers of primary forest were cut down this year. This resulted in a number of fire spots that is the largest in the whole INPE history. That is 180,000 individual fire spots observed in the Brazilian Amazonia this year. So this has a tremendous impact on the ecosystem, on the health of people, not just because of the emission of greenhouse gases like CO2 and methane, but also production of ozone, particulate matter, aerosols, and so on. Which are these effects? You know, in terms of ozone, ozone is toxic for the plants. It reduces primary productivity significantly, and we are observing concentration of ozone 2,000, 3,000 kilometers downwind of Amazonia in very large concentration, around 40 to 50 parts per billion. So this has huge impacts on the ecosystem locally and also globally. And it's important to always remember that the cheapest way to reduce the CO2 emissions is reducing deforestation. So right now, globally, deforestation is responsible for 13% of greenhouse gas emissions, and is the cheapest way, and it can be done, and can be done very quickly in terms of reducing CO2 emissions. So I hope Brazil will implement the policies for the next few years to get zero illegal deforestation, like the Brazilian INDC is promising in the Paris Agreement.
Great. We'll now open it up to questions from reporters in the audience. Please state your name and affiliation.
My name is Mike Roddy. I live in the Bay Area. I'm an author and have published a magazine and newspaper articles, et cetera, and write in journals. But more than that, I'm a builder. I've been a builder for 25 years, specializing in light gauge steel, and built after fires, for example, in Malibu, and in Kobe, Japan, which was a fire as well as an earthquake. We have a team now to rebuild Paradise with light gauge steel and all non-combustible materials. Not only did people die from the fires, they died from the toxic materials that were released by the Oriented Strand Board and so on. But enough about me. I want to ask you guys questions after you meet the rest of the audience. Or should I just go ahead and talk? Okay. A data point that I learned from Dr. Harmon at Oregon State was that when you cut down a forest, about 15%, or excuse me, 85% of the carbon is released into the atmosphere. When a forest burns it down, about 15% of the carbon is released into the atmosphere. The rest, or excuse me, I might have that backwards.
No, I think you're right.
Yeah, but you understand my point. It's much worse for the environment to clear-cut forests and our carbon budget than it is to just allow them to burn, because only a small percentage ends up going into the atmosphere. The rest is a soil amendment. So the point I want to get around to making is we're fighting to avoid having to rebuild with lumber in these places because it's 3% cheaper than steel, and we're running into problems, and I didn't succeed. Yeah, my question is, do you support the idea of prohibiting lumber construction and the wildland-urban interface, which would result in safer housing and fewer deaths?
Well, I mean, I think that with the multiple tragedies in California, with the recent really severe fire seasons in 2018 and 19, that there really has to be a whole reimagining of both the building codes and the structuring of communities, making more safe spaces that would have really helped communities like Paradise. So I can't speak specifically to steel versus lumber, but I do know that we really have to potentially focus on designing communities in a way that are in the wildland-urban interface that protect them, including, putting in place new standards to limit embers from moving in, and really, I guess, fire hardening structures. And I know that California is in the process of continually upgrading those standards over time, and they have, but it's something that really deserves more attention. So from our perspective, I think we are more scientists thinking about these broad interactions between climate and deforestation and fire regimes, and so we're not exactly the right audience for you to answer that question directly, but I think it's really an important one, and it's something that we have to we have to think more about. And I just can't speak directly to steel versus wood because that's not my area of expertise. I don't know if someone else would like to say something.
Yeah, sorry. Alistair Smith at University of Idaho, we did a paper for Bioscience a couple of years ago trying to look at this question for how to manage ourselves in landscapes, and materials was one element of it. So obviously, if we're gonna be in those flammable landscapes, we wanna build accordingly. But a lot of it, as Jim said, it's the whole design of the community. Do you design it for fire to roll through, or do you try to keep it out? With the materials, one of the big issues you mentioned is it's the blizzard of embers that usually gets you, and a lot of those can go right into the same house. So if the insides are flammable, you might still have a problem, even if your structure stands because of the steel. So unless it's a total design issue, you're not quite gonna get there.
I just would like to address your point about the emissions from clear cut and from fires.
Yeah.
So I think this is important to remark that in the Amazon region or in other parts of Brazil, usually wildfires are related to deforestation. So when you burn the forest, you make the forest more vulnerable to other types of stress, and usually sometime later the forest is cut down. So I think it's not that, this comparison is not that simple, because you have to consider the whole process that is involved in wildfires in different parts of the world. So in the savannas of central Brazil, fire is a natural determinant of the vegetation, but if you change the fire regime, so you can increase the damage to the natural vegetation, that results in increasing mortality rates. So it's an important point to consider as well. So.
Hi, Amy McDermott. I am with Front Matter, which is the magazine section of the academic journal PNAS. And I'm curious, for all of you, what do you consider the most pressing, big, overarching research questions for global fire today, from California to Brazil? And are there any preliminary answers to these questions?
There are many.
Yeah,
We can
I know.
start. Yeah, we could spend hours responding to your question. The first one is that, you need the global climate models to pick up, the right responsibility of the fires in terms of emissions and effects, We are far from that. We were discussing, a few minutes ago before this talk, that, for instance, global inventories of fires, normally are underestimating by a factor of 2 the real emissions. And the models themselves, are still quite limited in terms of knowing the effects of these fires, in terms of aerosol emissions, interactions with the clouds, and so on. So that is, for me, would be the most pressing question in terms of fire research right now. Yes.
I guess I can take a stab at it too. My desire would be to actually understand the place of these fires in the normal system. Basically, it's not a question of, is this fire bad, that fire good, whatever. It's, are we changing what we call a fire regime, the typical behavior and timing and effects of fires. So when we talk about climate change, we get fires, but not every fire is directly due to climate change, and not every fire is bad, even if it is due to climate change. What's the concern is, are we shifting it such that these fires are going to be different than they were before? Because if they are, all the vegetation will change as well. And ideally, if we understand that, we can start making the models show us where this is not just a problem today, but where it's likely to become a problem. Because, for example, a couple of years ago, Gatlinburg, Tennessee suddenly burned in a way they've never seen before. Well, those areas are getting somewhat drier and drier. We'd like to know if that's going to become at least maybe not common, but at least an endemic phenomenon, because we have to plan accordingly for that. So basically, I want to know if fire regimes are changing so that I can have an idea of how the vegetation is going to respond.
Yeah, I think this is an important point, because we are still trying to understand how past fire regimes shape the vegetation that we have now. So, and how this changes in fire regime will shape the ecosystem function in the future. And also, I think a key aspect is how the interactions between human population and fire will change with climate change. So as I mentioned, there are some ecosystems that really are dependent on fire, and fire is managed by traditional communities. And many of these traditional communities are now facing difficulties to climate change to run the traditional practices using fire to shape the vegetation. So.
Right. Those are all great. I would add to this, I think a grand challenge in fire research is fire prediction on daily to subseasonal to seasonal timescales. We need to have better information to predict how a fire will spread. We need to be able to predict further out into the future the weather conditions that lead to these extreme events. And we need as well to be able to predict the intensity of a fire season, to be able to place resources, so fire suppression resources, firefighters in the right place. And so in this meeting, there's a lot of work on this S2S prediction, and it really needs to extend to fires. And then the other element I would add, I think a grand challenge is our observation system for fires. Right now, we can make good fire measurements at maybe 10:30 and at 1:30 in the afternoon. And we really need an upgrade in our global system to measure fires around the entire diurnal cycle, every several hours, in order to really both identify fires that are burning in between these areas that might be contributing to deforestation, but also really prepare people who are fighting fires with the information to better place their resources and protect lives.
Yeah, I agree with everyone. Those are all very pressing issues. I'll add on to the vegetation effects from fires, and so one other way to view that is if, for example, in California, fire season is now almost all year round. And so it's really important to understand like post-fire vegetation effects, to understand how vegetation is going to regrow and possibly impact future fire risk. So that's something that I'm going to be studying in the future, but I think it's a really pressing issue as well.
Yes, you had a question over here?
Thanks, everybody. I'm Tim McDonald from NPR. Mercedes, I had a question more about the deforestation issue. And you were mentioning some of the political challenges in Brazil. I'm wondering if you could talk at all about the role of the private sector in contributing to deforestation. Particularly, there's been a couple reports over the last few months about especially American companies, American agricultural commodity companies that have committed to eliminating deforestation from their supply chain by next year, but doesn't look like they're going to be able to do that. And just wondering if you could talk about, what role you see for the private sector as contributing to this problem, and maybe how steps they might be able to take to do a better job of eliminating deforestation from their supply chains.
I think that the private sector is an important part of this equation. So as you mentioned, the political changes in Brazil are weakening a lot of the public policies that helped Brazil to decrease deforestation rates in the last 2 decades. So we have some initiatives like the Sustainable Soil Roundtable that was quite successful. And unfortunately, this initiative is only restricted to the Amazon region. We would like to see this also be applied in other Brazilian ecosystems like the Cerrado, like the savannas in central Brazil. That is the new deforestation frontier. But also when we talk about the private sector, actually the private sector is quite diverse. Even if we talk about the agribusiness in Brazil, we have part of the agribusiness sector in Brazil that is quite advanced and is quite careful about the environment. But there is other part of the agribusiness sector in Brazil that is quite conservative, that actually holds a lot of political power in the Brazilian National Congress. So, and this is a sector that is not homogeneous. But I think that without the private sector and without the pressure of consumers, we are not going to succeed in terms of the control of the deforestation, because most of the deforestation is driven by the export of commodities. So we really need to make these teleconnections and share the responsibility for the environmental situation and the countries that are producing the commodities exported to China, to Europe, and to the US as well.
So if I could just follow up on that too, one of the things you got to be careful is the kind of perverse effects we call it, where, for example, with soybean, they committed not to deforest, so they bought up pastures, so they didn't deforest. But then the ranchers moved and deforested to make new lands open. So yeah, unless you have a kind of an integrated system, you can just displace the problem, not actually, or make it look like you don't have deforestation in your chain, but in fact you do.
John?
Hi, Jonathan Amos, BBC. What's the status of our remote sensing capability in terms of the sensors that we have in orbit now and what we'd like. MODIS has, I think, been a tremendous asset. MODIS is pretty old. The VIIRS instruments, I think, on the new polar satellites are there. Europe providing something through the likes of EASA and stuff like that. But, how do you see it?
Okay, we can both contribute. So that for thermal, there's different ways you can detect fires. One is through actually seeing the fire scar just in a visible light that's reflected off the Earth. And there's really new advances there with Sentinel from the European Union, Sentinel 2A and B, and also with this US Landsat system. And then the thermal anomalies are really, at 1:30 in the afternoon, we have this VIIRS instrument on Suomi and NOAA 20. And for the foreseeable future, we have this in the NASA and NOAA systems. We'll have 1:30 a.m. and p.m. observations of the thermal anomalies. And what I was talking about earlier about the gaps are really that we would like to have those around the clock every couple of hours. I believe that Sentinel-3 or follow-up Sentinels will as well have this kind of moderate resolution capability. But again, a lot of the remote sensing for the Earth is, a lot of the overpass times are designed to be in the middle of the day because they're trying to look at a broad suite of environmental change. And so, that's to me, those are some of the big sensors that are really operational today.
Yeah, one that may help with that is the GOES systems, which will image every 5 to 10 minutes. They have a different resolution, but they're still working out the bugs on what they see.
Right, and they're very coarse.
So I think they're down to 500, but it's still, everything we do in fire is ad hoc because no system was designed to look at fire. We get a system and then you figure out what you can do to try to, say, detect a fire or figure out what the fire did or something like that. And we're pretty good at doing those things, but nothing was designed to actually monitor fire. So we don't have things that help us look at it during the day or night or how it's evolving or at a scale that would make sense. We're just trying to put it together. So one of the challenges we have is no one sensor can do it all. You can use some to maybe detect things, other ones to actually figure out what they've done and how they're, working together, what they were related to, whether it's the vegetation or the moisture. So it's being able to integrate all that. So we have a lot of potential tools out there, but like I said, they're all ad hoc. We make do, but nothing was designed for fire.
Okay, coming. Getting my exercise.
Hi, I'm Molly Bentley with Big Picture Science. It's a radio show, and I live in the Bay Area. And having lived through some of these fires, and in fact, I know one of the reporters who's been covering the fires for KQED is sitting on the end here, and she's done a terrific job. So we know that some of the knockoff effects are the health effects in the area. The air is terrible. But then also, if you live in this area, you know that what comes after the fires, if we're lucky, is we get our rains. And so in some places, you increase the likelihood of mudslides and other catastrophes due to the water that we so desperately need in this state. So when you talked about a better placement of resources, or you're thinking about the post-fire risks, is the increased threat of mudslides one of those risks that you're considering?
Yeah, I think that's definitely another pressing thing, looking at the, hi. I think that's another really important thing that we need to look at, and there has been recent work looking at California's, it's called California, I think it's called like weather whiplash or something, where you're getting a very dry season and then a very wet season right after it, and that's, in the future, that's expected to increase the frequency of those kind of events. So I think it's definitely somewhere where we need to better understand the fire effects on land and vegetation to be able to kind of predict when we would get, where and when we would get landslides that could impact people. And I'm not very familiar with that literature right now, but it's definitely something that is going to, based on climate model projections, could happen more often because of this increasing very dry to very wet conditions. So,
Yeah, I would just add to that, yeah, I mean, the Thomas fire in Santa Barbara, there were devastating mudslides after that, and it is a really important element of the full fire impacts in California. I think there are echoes of fires. I think it's been known for a while. We've had an appreciation that there are these human health effects. And I know that, unfortunately, things like the Camp Fire, there's been huge, just really huge effects on the Bay Area of the smoke. But I think there's a growing appreciation that there's this economic displacement. There's the evacuations. There's the follow-on now with our utility trying to adjust, with the blackouts, that these there's a legacy, a memory of these extreme fires that extend for many years, and it really is a disruption to our economy. And I think we need to be broader in thinking that it's not only air quality, it's really the mudslides, but I would also place in that same category the economic disruptions and the effects that are propagated through the evacuations, and just how disruptive those are, even for the fires that don't lead to mortality. That can be, I think, really devastating to many people in the community that are. Yes. Right, yeah, absolutely. I'm well aware of that issue. I could talk to you after about it. It's quite striking. And people have described that, right, as the first climate-driven bankruptcy of a company.
Yeah, but the thing is, we got to design around that, not try to control it. That's what we've been trying to do for decades, and we're losing. Fires are getting bigger and more frequent no matter, and we're spending over $2 billion a year right now trying to suppress. So the question is, how do we create an infrastructure system and our social system to kind of deal with this? We're going to have smoke. It's not a question of smoke or no smoke. It's a question of how much smoke and when. So you can either try to, say, prescribe fires. You'll have some smoke, but you'll burn under reasonable conditions. Or you're going to wait till the worst conditions and have a terrible fire with huge impacts. So like, California has huge impacts with the smoke. Where I work, Indonesia in 2015, the estimates are 100,000 died from that smoke event. So it's not just a problem here. It's a problem in many places, but we're going to have to work with the system, not try to control it.
Are there any other questions from reporters in the room? Okay.
I'm Kevin Stark with KQED. Jim, you were talking a little bit about the role that climate change plays with some of the wind-driven fires,
Yes.
How warming isn't really pressing the winds, but it can impact the humidity.
Yes.
Can you explain that a little bit more? And
Yes.
also, you were talking about the Santa Ana winds. Is that something you see with the Diablo winds in Northern California as well?
Yeah, I think yes, I think they're very similar phenomena. There's like a high pressure that develops over the Great Basin and over Utah, and the air kind of descends there and is flushed out, heats up as it's descending, moves out through these canyon passes, though the positioning of the high pressure can, I guess, determine whether it's a Diablo or a Santa Ana-driven event. And so I think there's two elements with climate change that we're really concerned with. Again, work that's we've been involved with, and some led by Alex Hall at UCLA, suggest the winds themselves may not intensify, but because in response to climate change, the land is drying, and so when that the air is normally dry, but when with it getting drier, the stomates are a little bit more closed, and you're at the end of a longer summer season where you're under more stress. So any humidification of the air by the vegetation as it's moving from the Great Basin into California, the vegetation can be under more stress, so it's not going to be able to humidify. So that's one element that I think is important, and that's why we think. And so in Southern California, what's a really important predictor of how bad the winds are for the fires is the relative humidity of the Santa Ana event. And there's actually differences in the humidity from one event to the next. They're always dry, but some of them will drop down to 10 or 20%, and some of them are at 30%. And the ones that get down to 20 or 10 are worse. And the other concern that we have that's really important is that, Danielle, you were talking about this, that there's a whiplash effect, but also there's some lines of evidence with some Earth system models that there'll be a compression in the length of the wet season. So if the same timing as Santa Ana events, then they kind of build up through the fall, and they actually peak in December and January, but they're not, at December and January, they're usually not a threat because we've had rains like we just did in California. But with climate change, there's moderate confidence that in California there'll be a compression. So we'll get more of our rainy season in the middle, and so that will leave a window in the fall where the winds will come and there's no rain, and so it'll basically lengthen our fire season. So it'll be with the same winds, you'll have the likelihood of more fire. That makes sense.
And it's also important to mention that in Amazonia, climate change is really is one of the components to bring more fires and also, of course, more deforestation. A recent paper from JPL here shows that the vapor pressure deficit in Amazonia has increased by 30% over the last 15 years. This means that the whole ecosystem is becoming drier, and then, as Jim mentioned, this affects how the stomata open up and send water vapor to the atmosphere, and then they do not fix as much CO2 as they are used to do in the normal photosynthetic process. So this can reduce the net primary productivity over the long term for Amazonia. So actually, this is something, the links between the hydrological cycle and the carbon cycle in Amazonia are very important.
Are there any other questions from reporters in the room? No? Great. That concludes our media availability and our final press event for the 2019 fall meeting. We'll see you next year back here in San Francisco.